This is part 2 of our notes. We'll deal with multiplying rational expressions as well as dividing rational expressions. We're going to start with this connection here. When I multiply 16 tenths times 5 twelfths, all I really need to do is multiply straight across the top and straight across the bottom. I end up with 80 divided by 120, which I can simplify to 2 over 3. We're going to do a more sophisticated version of just that today. As I look at part A here, I want to multiply the numerators together. I'm going to multiply, let me highlight it here so we can see what's going on, 2 times 15. 2 times 15 is 30. Let's go ahead and deal with our x's. X to the 4th times x squared will be x to the 6th. And finally, sorry about that, I have y to the 5th in my numerator. Let's move down to the denominator. I'm going to multiply 3 times 8, and I'm going to get 24. Next, I'm going to multiply x squared times x to the 3rd. That will be x to the 5th. And then finally, I'm going to multiply y squared times 1. So I'm going to have y squared in my denominator. As you can see, I've color-coded things. That allows us to see what I can simplify. 30 over 24, both of those numbers are divisible by 6. So my fraction here will be 5 over 4. That's as simple as that will get. Here on my x's, I have x to the 6th in the numerator and 5 in the denominator. If I were to subtract my exponents, I'd get x to the 1st, and that will stay in the numerator. And then finally, I take y to the 5th divided by y squared. I will get y cubed, and that's my simplest form of that product. The other type of problem we'll see will look more like this. Now, the one kind of odd thing about multiplying these rational functions is we don't really multiply. We don't want to distribute. We really want to factor and cancel. So first, I'm going to factor what I can here in the numerator. I have a 10 as a common factor, and what's left is x minus 4 times x plus 3. In my denominator, I'm going to factor x squared minus 6x plus 8. That will be x minus 4 times x minus 2. And then here on our last term, 5x plus 15, I'm going to factor out a 5. I like to put that out front here, and we'll multiply by x plus 3. Just like we saw on our simplification problems up above, we now can cancel common factors and simplify 10 divided by 5. That's going to be 2 over 1. So our final answer here, let's put it in black, will be 2 divided by x minus 2. And again, x must not equal any value that makes my denominator 0. So 4, 2, negative 3. Even though we canceled those factors, they still affect our domain. Next, we're going to look at a few problems of dividing rational functions. Well, dividing isn't much more complicated. We should think about division as multiplying by the reciprocal. So if I have 8 over 22, I can rewrite this. Instead of dividing by 16/11ths, I can multiply times 11 over 16. If I see it at this step, I can simplify my fractions. I can actually do that a couple times. This will be 1, that'll be 2. So once I multiply everything out, I should get 1 over 4. Big idea here, division doesn't really change things for us. We are multiplying by the reciprocal. Let's look at a few examples, and then you'll be into your practice. First, I want to rewrite this division problem as a multiplication problem. The first term, the left-hand term, will remain unchanged. I don't want to do anything to it. I'm going to change my division sign to a multiplication sign and find the reciprocal. So instead of 16 over 9y to the 5th, it will be 9y to the 5th divided by 16. Now I can work straight across. If I'd like, I can simplify here. I see that 16 and 4 will simplify. I'll see that my 9s will cancel. And let's see where we end up. I have x cubed y to the 5th all over 4x squared. Maybe we notice that this isn't fully simplified. I know it's not simplified because I have an x in the numerator and denominator. My fully simplified form here, because I have 3 x's in the numerator and 2 in the denominator, 1 will remain in the numerator. My y to the 5th is unchanged, and we're divided by 4. There's my final answer. One more problem together. We'll look at part B. Just like we did last time, we're going to rewrite this problem as a product first. If you'd like, you can factor as you go. So as I look at this numerator here on the left, I can write this as 2x. Let's see, minus 4 over here plus 1 here, all over x minus 3, x plus 3. Be careful, we need to flip things around. I see that I have a 4 come out here, so I can rewrite this denominator as 4 times 2x squared minus 7x plus 3. So when we go ahead and factor this, this will be in the numerator, right? The denominator becomes the numerator. It's going to be 4 times 2x minus 1 times x minus 3. Finally, I want to factor my 4x squared minus 1. That will be 2x plus 1 times 2x minus 1. Now I want to find any common factors if I have them. I want to cancel them if I can. I have a 2x plus 1 in the numerator and denominator. I have a 2x minus 1 in both places. I have an x minus 3 in the numerator and the denominator. I think that's as far as we can go. So I'm going to rewrite my final answer as 4 times x minus 4 over x plus 3. Or I could distribute that 4 and get 4x minus 16 all over x plus 3. Remember, division is no different than multiplication. We just want to multiply by the reciprocal. I'll leave it to you to finish the you try problems as well as the practice problems attached to this packet.